All right, in this video, I'm going to give you some tips for the weighing project and the usual reasons. I want you to have fun. I want you to learn a ton. I want you to design a product that others will use. I want you to minimize your efforts, particularly no busy work. I want you to be able to get a resume builder and, of course, get a great grade. On Tuesday after break, we're going to be doing a critique. And here's what Wikipedia says that critique means. So it's discipline, systematic. Discourse, which means communication, and that's a little bit too academic, so I just simply wrote it like this. It's a method for looking at technical work that involves analysis and questioning by experienced professionals. And so for me, this is like having great ski coaches helping me get better at skiing. It's a very fast process for improving. Since this is so important, I decided to ask a bunch of my friends to help me in the critique. So I called up a bunch of my friends who are experienced and passionate professionals. Some are engineers, some are not engineers. And I asked them, are you down for helping U of I ME students become good at designing experiments? And boy, did they respond. Nearly everyone said, I'll come to the critique and help. I'm down for this, count me in. Or they had a commitment. So there might be 3 to 6 people after the critique in addition to myself. Tip number 1 to help you do well on this project is understand the why. So here's the basic argument. As engineers, we design products. And most of us are very passionate about these products. And the products we design, we want them to work very well indeed. And so the engineering approach is we want to get data almost right from the get-go. So almost the first thing we do when we're designing products is we design an experiment for testing the quality of the product that we are designing. Let me give you an example. So as an engineer, I'm very interested in designing a much better ski. And in particular, to get traction, we sometimes use climbing skins, and they're a real hassle. And sometimes we use a waxless base, and those don't work very well. So I'd like to design a better product. And so I want some way to design a backcountry ski that works better. So I have that passion to do this design. And so if I was doing this project right now, one of the first things I would do is to design an experiment to measure the base of a ski. And I'd want to know what is the frictional force if you're gliding, and I would want to know what is the frictional force if you're climbing, because I want to be able to climb uphill and then glide very smoothly down the hill. In the context of your project, you're designing an apparatus for measuring weight. This is simply a scale. And so what you're going to really be focusing on, though, is designing an experiment to measure the quality of that scale. Did you design a good scale? So this is the real focus of this project, and the goal is to help you out with anything you ever design from now until the end of your career. Tip number 2 is to do great experimental work. And great experimental work starts with creating great results, something that's very useful to people. And here's how to think about this. On this project, if you have a team of 2, you should be spending about 10 hours. And if you were to go to work now as an engineer, you're going to cost about $100 an hour. And so your manager is spending about $2,000 to get this project done. And your manager is going to ask the question, what am I getting for my $2,000? And out in the real world, results matter. So if I was doing this project, here's some of the results that I would think of delivering. And I'm just giving you an example here. I would deliver to my client an experimental approach that's useful for testing any scale. So the results section of my report says, in Appendix B is a step-by-step approach for quantifying the performance of any scale. I would deliver a design. And so I'd say in Appendix C of my report, you can see the diagrams needed to build a scale with a FSR. And I would list the specifications. So I'm delivering a design. I would deliver experimental data that characterizes the exact scale that I built. This shows how my method works and also shows the quality of the scale that I have designed. And I would deliver a recommendation. I recommend using an FSR for a scale. I do not recommend it. Here's why. Or if you use it, here's how good you can build a device, etc. But the key focus is results matter. In your report, in the very end of it, say, here's what I got for you, and just lay out really useful results that nearly any engineer would want. So to do great experimental work, the number one thing you want to focus on doing is delivering results that are super useful. The number two thing you want to do in the context of doing experimental work is make sure in your report you tell your reader exactly why you're doing this project. And so some of the why reasons that would come to mind for me is FSRs are very common, and a lot of stuff on the internet says you can't build a weighing scale out of these. Well, it'd sure be nice if you could, and I'd like to know how good of a scale can you build if you try this. So find some rationale that's going to be very relevant to a lot of people, and make sure you just clearly lay that out in your project. So number 2B is give a motivating rationale, and number 2C on how to do experimental work is do a great literature review. And I'm going to build you a lesson on how to do this, but literature review is a part of every research project, every science project, and if you just Google how to do a literature review, you'll find a ton of information. Tip number 3 is to do great lessons learned, and these will go in Appendix A of your report. Now, why would you want to do this? Well, here's the basic idea. At some level, all of us know if we want to learn something, we've got to do it ourselves. Then we've got to get feedback from either coaches or the real world, and then we have to reflect and grow. And we have to repeat this cycle over and over. And this cycle is called learning from experience, which I abbreviate as life. So learning from experience. And when you can do great lessons learned, you're simply demonstrating that you can learn from experience. Super important in the real world. So how do you do great lessons learned? And basically in your report, you want to do two things. You want to do mini lessons learned, and you also want to have lessons learned that add value. And how do you add value? Your lesson learned is very valuable and very useful to nearly any professional. The more your lesson learned generalizes to other projects and problems, the more useful it is. You want your lesson learned to be actionable. It's an idea that anyone can apply. It's a skill that anyone can apply. And you want to frame your lesson learned with disciplinary language. Tip 4, write a great report. And there's an easy way to do this. Use the IMRAD approach, which I'll show you in a second. And then when you have detail information, kick that into appendices. So your lessons learned should be in Appendix A. If you have a math model, put it in Appendix B, for example. If you have extensive data, put it in Appendix C. But the key idea is make your report just short and sweet, to the point, and detailed information that people are going to want to look at. Throw in an appendix. Okay, you can Google IMRAD, and this is the most prominent way to structure a scientific paper. Wait a minute, are we doing science here? Doing research? And absolutely, doing an experiment design is doing science or doing research. We're here to learn experiment design, we're here to learn science, we're here to learn how to do research. That's what we're doing. As this article says, IMRAD is an acronym, and it stands for Introductions, Method, Results, and Discussion. And so all experiments, all scientific papers, theses, basically all research follows this same structure, and it makes it very easy for the reader to follow what you're doing. And Wikipedia lays out what you need to have in each section. And I'm going to add one piece here. It's really important to conclude with results or conclusions, where you just lay out for your reader, here's exactly the results that I've produced during this work. And you see this sentence here, the IMRAD structure, it dominates quality writing in the sciences, and that goes for engineering too. So I've made a few refinements on the project assignment, and these are on the website, so learningfordoing.com/theweighingproject, as shown there, and I'll just highlight the main changes. So in your report, I asked you to use the IMRAD approach, and I gave a link to that Wikipedia article. And I asked you to put in lessons learned into your report and put them into Appendix A, not in the body of your report. In terms of your talk, I reduced the time from 4 minutes to 3 to 4 minutes. I'd like you to shoot for 3 minutes. And here's the key things you want to do in your talk. So the 3 most important things is, number 1, you want to explain how you quantified the quality of this apparatus you're designing. Number 2, you want to explain how did you build quality into your experimental work? What are the specific things that you did so that your work would be considered great experimental work? And in your talk, present your very best lessons learned. I'd probably present 2 or 3. You want to keep it short and sweet because you're doing Pachachka. The last refinement I made is you're going to post your final report to Dropbox. And I've already sent you the link to Dropbox, and Dropbox is super cool, and probably half of you at least already are using Dropbox. And the reason we're going to use Dropbox is this will allow the members of the critique committee, i.e. my posse, to all have access to your reports before you do your presentations. And this way they can come in prepared. Here is how we're going to do the critique. So I'm going to call on a team, and you're simply going to play your YouTube video. And so be ready to go. What I would do is email myself the link and then just log on to Vandal Mail, and you have the link, click on it, and you're up and going. Then the team or the individual will answer questions from the panel. So we're going to try and ask you questions that are going to really challenge you and help you learn. Like the last critique, all the students themselves are going to be writing feedback on the feedback form, and we're going to use the exact same feedback form. And on this particular project, not all students will present. And the main reason, the whole purpose of this is learning. And I want to get enough people out presenting in the critique that we can get the learning we need. We don't need to see everyone, and if we have everyone, it's simply too much time in the classroom. And I want to kind of keep this down. Here's some tips for doing well at the critique. Number 1, recognize that the reason for doing this is so you can learn experimental work, which is super important and super fun. Recognize there'll be about 6 professionals at the critique, might be down at 3 or something, but there's going to be a number of other people, so be ready for that. And what you want to really show the professionals is that you can do great experimental work, and plus, you can find lessons learned. As you're showing your work, use data and evidence. The words are show me, and avoid opinion and emotion. So just lay this out in your video. When you get asked a technical question here, it's totally okay to state, I don't know, I'll get back to you on that, and then follow up. But what you don't want to do is make something up. So answer to the best of your technical knowledge, and if you're not really sure, say, I'm not really sure. I'll talk to you about that afterwards, or I'll look that up and get back to you. But do not make things up. A really key life skill is don't argue. When one of these experienced professionals suggests something or asks you a question, don't argue with them. Simply say, that's a really good idea, and write it down. Chances are you'll learn a lot from that, and also it's much more respectful. And speaking of respectful, that's kind of the tone that everyone wants to have, and it'd be really nice to say thank you to some of these people who are donating their time to help you learn. Here's some summary of the tips I just gave you. As engineers, we love to design things. And when we design things, we want them to work well. So one of the first things we do as a design engineer is we design an experiment. And that's why we're doing this project. So you can learn to design an experiment that will help you be a better designer. Tip number 2 is do good experimental work. And in your report, you want to make sure, here are the results. Give people something that's super useful. Tell your reader exactly why you're doing the work, and come up with something that is really motivating to you and to other engineers. And do a great job, and this again is in your report, of reviewing all the existing knowledge and building on it so you're not reinventing the wheel. Tip 3, make sure your lessons learned are useful and valuable. They generalize to many projects and problems. They're easy to act on or apply the idea, and that you use disciplinary language. Number 4, IMRAD your report. There's a standard structure that everyone expects. If you use this structure, it'll be very easy for people to follow that are experienced, because they're expecting this structure because they've probably seen hundreds of reports and journal articles written with this exact same structure. And then put all your detail in appendices. That concludes this presentation. Hope you've enjoyed the video. We'll see you next time.